there's a very noisy construction, but why wouldn't we like try to better us better ourselves in the worst environment possible? This is nowhere near as the worst environment, but let's go.
So what is data structures? So if you see, it is a way to organize the data. Now what do we mean by that is when we want to program anything and we have a huge amount of data. So we basically take the help of data structures to organize the data into the memory. So why we organize the data? It's because after organizing the data, it becomes very easy to process it. Now what do we mean by that is if we have an organized data, we can very much efficiently access and process it. So here let's say if we take an example, let's say if you go to a library where you find these unorganized books. Now if someone asks you that bring a book related to algorithms from this unorganized books of let's say any particular author. So now here you can see that as books are unorganized, there is a problem because in order to find a book related to algorithm for a particular author, you need to find that book in this unorganized books. So it will take a lot of time to find that book. Now let's say if these unorganized books are basically organized like this in a particular shelf, and now if somebody asks you that go and find a particular book related to algorithms of a particular author, so it would be very easy for you. You will just go to that particular section where the books related to algorithms are kept and you will just find that book. So here you can see that books can be related to the data, and when we organize these books, you can similarly relate it to the data structures where we are simply organizing the data so that it becomes easy to process it.
Right.
So this is the basic introduction about what is data structures.
Okay.
My name is Munzir Dale. I'm a professor of electrical. The partnership that we have with professional education has allowed us to create a new course.
Let's skip this.
Now let us see what are the types of data structures.
So yeah, so like what I would apply this to is to like World of Warcraft. All of my analogies are to World of Warcraft or a video game or whatever. So data structure, to me it sounds like how I'm gonna store all the information organized so then I can go fetch it.
So basically there are two types of data structures, linear and non-linear. Now when we talk about linear data structures, they have the data elements arranged in a sequential manner, and they are arranged sequentially so that each member is connected to its previous and next element, and as they are connected sequentially, it becomes easy to traverse them, and usually the traversal is a single level. Now these type of data structures are very easy to implement because they are stored sequentially in the memory. So some of the examples of the linear data structures are as follows. So here if you see array, linked list, stack and queue. So these are the linear data structure where the elements are stored sequentially and mostly they are single level. So the other type of data structure is non-linear data structure. So if you see by this term non-linear, we mean that the data elements inside these data structures are not in sequence. They are basically connected to one another through different paths. And as in linear data structure, they were single level. Here, they are basically stored in multi-level. And as they are multi-level, so in order to traverse each and every element in this non-linear data structure, takes some amount of time. Now as they are multi-level, in order to traverse each and every element in this non-linear data structure is bit difficult. And compared to linear data structure, they are not easy to implement. So some of the example of non-linear data structures are tree and graph. So here if you see, if we take an example of an array, the data is arranged sequentially and it is basically in a single level, so we can traverse it sequentially. So it is very easy to implement. But here if you see that non-linear data structure are multi-level, So here it's an
Right.
example of a tree where the topmost element
So this is very important. Okay. So the one I know is arrays. It's just a list, and then there's linked list. There's stack, there's queue, and these are linear. So non-linear means that I start at a root and I can just go take a path. There's trees.
is the root. So
There's
here if you
graphs.
see, these data elements are connected through multiple paths and they are in multiple levels. So here we discussed about the data structures and we also discussed about the types of data structures, which is linear and non-linear. In linear, few examples are array, linked list, stack, queue, and in non-linear, we have tree and graph. So in our upcoming videos, we'll discuss more about the array, linked list, stack, queue, tree, and the graph data structures. So I hope you like this video. Thanks, have a nice day.
Yeah, this guy reminds me of Slayer Music 1. Hi, and welcome to my guide.
Hello everyone. So in this section, we'll discuss about a basic introduction to algorithms. So what is an algorithm?
An algorithm is a set of instructions to perform a task or solve an given problem.
So if you see the formal definition of algorithm, an algorithm is a set of instructions to perform a task or to solve a given problem. So what do we mean by set of instruction is that, let's say we are given a problem. So there would be a sequence of steps or there would be a set of instruction. If we follow that, our given problem will be solved. So let's say for example, we are aware of a recipe book. So it is nothing but a
Recipe book is a collection of recipes. Yep.
collection of recipes in which each recipe provides an step-by-step instruction to prepare the food. So let's say if someone asks you that provide me the recipe to prepare a tea. So basically the steps inside that recipe would be, the first step would be that we need to boil water. Second would be put tea in the teapot. The third step would be that put that boiled water into the teapot. So after adding the hot water, the fourth step would be that as we have hot tea,
Whatever this is.
so we just put that hot tea into the teacups. So the fifth step would be that do you need sugar? So there is a choice. If yes, then put that sugar into the teacups.
I think I have a problem here. No, I remember what I did. I remember what I did. I'm okay.
And if no, then do nothing. Put that. So there is a choice. If yes, then put that sugar into the teacups. And if no, then do nothing.
Right.
And the last step would be stir, drink and enjoy the tea. So here if you see that this recipe of preparing a tea is very much similar to an algorithm, which is nothing but set of instructions which help us to solve a given problem. So here let's say we take an example that we want to print the average of 3 numbers. So we are given 3 numbers and we want to print the average of it. Now let's say you want to write an algorithm to solve this given problem. So the steps you would provide would be First, you will perform the sum of three numbers. Store that sum into a variable by name sum. Divide the value stored in sum by 3 and store the value into a variable average. And finally print the value stored in the average. So this would be the sequence of steps which you would perform to print the average of three given numbers. And this set of instructions is nothing but an algorithm. So here, if we transform these 5 steps into the code, then here we have a method findAverage where we are given 3 numbers A, B and C. So we perform the sum of 3 numbers here. We store it in a variable sum. So here we are storing it here. Then we are dividing the sum by 3. So here we are storing it here. Then we are dividing the sum by 3. So whatever the value is there in sum, we are dividing it by 3. We are storing the value in variable average here. And finally we are printing the value stored in average here. So this sequence of steps is nothing but an algorithm. And usually when we are given any particular problems, we derive this sequence of steps and we try to implement it in particular language and write the logic around it. And finally, after performing all the steps properly, the given problem is solved. So friends, this was the basic introduction to algorithms. In our upcoming videos, we will discuss the algorithms and data structure in great detail. I hope you like this video. Thanks, have a nice day. Hello everyone. So in our previous section we discussed about a basic introduction to algorithms and data structure. Now in this section we'll mostly discuss about the analysis of algorithm. So what do we mean when we say analysis of algorithm? So before that we saw in our previous section that an algorithm is a set of instructions which we use to perform a task or to solve a given problem. So when we talk about analysis of algorithm, this set of instructions are very much important. And why they are important? Because in order to solve a given problem, there can be several different algorithms. So our analysis mostly deals in finding the best algorithm which runs fast and takes in less memory. So why we actually do that? Because let's say we are given a problem and we have 2 to 3 algorithms to solve that problem. But out of the 3 algorithms, one algorithm let's say takes 1 second, the other takes 5 seconds and the third one takes 10 seconds. And similar with the memory. So we usually do analysis of those 3 algorithms and we take that algorithm which takes the less time, because if we take an algorithm which takes more time, then slowly our system will degrade and we have these performance issues. So let's say for example, we are given a problem to find sum of first n natural numbers. So the n natural numbers would be 1, 2, 3, 4, 5, 6 and so on. So to our method, we are given a value n and we want to find its sum. So let's say if we input n equal to 4, so the output we get is 10. That is 1 plus 2 plus 3 plus 4. So 1 plus 2 gives 3, 3 plus 3 gives 6 and 6 plus 4 gives 10. So this is the sum of first 4 natural numbers. And similarly, let's say if we input n equal to 5, then we get output as 15. So when we do 1 plus 2 we get 3, 3 plus 3 we get 6, 6 plus 4 we get 10 and 10 plus 5 we get 15. So this is the sum of first 5 natural numbers. Now let's say we want to solve this problem.
The biggest mistake that people make when it comes to their memory is not understanding how it works. They think that their age, their genetics, even IQ means that they can't.
And let's say we have these two programmers who come up with their own algorithms. So Ramesh comes with one of the algorithm and Suresh comes with yet another. Algorithm. So here Ramesh is trying to find the sum of first n natural numbers using the mathematical formula, which is n into n plus 1 by 2. So here let's say if we input n equal to 5, so it will be 5 into 5 plus 1 by 2. So 5 plus 1 is 6. 6 divided by 2 is 3. And 5 into 3 gives 15. So this is the mathematical formula which is directly using to find the sum of first and natural numbers. And here Suresh has written one algorithm which is what we discussed in our previous slide, that 1 plus 2 plus 3 plus 4 plus 5. So what he's actually doing is he's creating a variable sum, initializing it with 0, and is providing a for loop which starts from 1. So here I equal to 1, and this I will go till it's less than equal to n. And once this statement gets executed, we are simply incrementing I by 1. So let's say if we input value of n as 5, so the start sum will be 0. So when this for loop will start execution, I becomes 1, and we check that 1 is less than 5 or not. So it is less than 5. Then we simply add 0 with 1 because some initial value is 0. So 0 plus 1 becomes 1, and 1 is assigned to sum. Now after this line, we increment I by 1. So I becomes 2. We check whether 2 is less than 5 or not. So 2 is less than 2. We get 3. We assign 3 to the sum now. Then we increment I by 1. So I becomes 3. We check whether 3 is less than equal to 5 or not. So it is less than equal to 5. So now as the value of sum is 3, we do 3 plus 3. We get 6. We assign 6 to the sum now. So sum becomes 6. Then we simply increment I by 1. So I becomes 4. 4 is less than equal to 5. So sum value is 6. We add 4 to it. So 6 plus 4 gives 10. And 10 is assigned back to sum. And then we again increment I by 1. So I becomes 5. We check whether 5 is less than equal to 5 or not. So I is less than or equal to 5. So sum value is 10. We add 5. We get 15. We assign 15 to sum. And then we increment I by 1. So I becomes 6. So now here you can see 6 is not less than equal to 5. So this for loop terminates. And the whatever value we have in sum, we simply return. So the value of sum is 15. So we simply say return 15. So friends, here you can see these are the two algorithms which can solve our problem of finding the sum of first and natural numbers. But there is no way to figure out that which algorithm is better than other. So in order to determine the best algorithm among these two algorithms, we usually check two things. One is the time complexity, that how much time these algorithms are taking to complete. And another is the space complexity, that how much memory this algorithm is taking to complete. So here in this section we discussed about the analysis of algorithm and its formal definition. In our upcoming lecture we will discuss more on what is time complexity and what is space complexity. I hope you like this video. Thanks, have a nice day.
If you're a business owner, then animated explainer videos are the best way to capture attention.
Hello everyone. In our previous section, we discussed about the analysis of algorithm, and we also discussed that there are two complexities which decides that how best is the algorithm. So one is the time complexity and the other is space complexity. So in this video, we will discuss about the time complexity of an algorithm. So what do we mean by time complexity? So in the simplest terms, it is the amount of time taken by an algorithm to run. So let's say we have written an algorithm and we try to execute. So when that algorithm finishes, the amount of time taken by algorithm determines our time complexity. So here usually an algorithm takes in an input, and in order to process that input, some amount of time is taken. So an efficient algorithm will try to process the input very fast, and a non-efficient algorithm will take some more time to process the input. So this processing of input by an algorithm helps in determining the time complexity. So here in our previous example, where we have these two programmers, Ramesh and Suresh, who have written these two algorithms. So here the input is same for both the algorithms, but here Ramesh is calculating the sum of first and natural numbers using the mathematical formula, which is directly putting the values inside this formula and returning the sum of first and natural numbers. Whereas here if you see that whatever value of n we are providing, we are simply running this statement that many times. So in for loop, it is running from 1 to a value less than equal to n. So here let's say if the value of n is very large, this statement will run that many times. So the time taken by this algorithm will be somewhat more than this algorithm, because here we are processing an input based on a for loop where this line is executing n number of times, and here we are simply using the value of n into this formula, which is directly returning us the sum of first and natural numbers. So definitely this algorithm will be more efficient than this algorithm, because the time taken by this algorithm will be less as compared to this. And we'll also discuss more about how to calculate this time complexity in much greater detail in our upcoming videos. But for time being, we just analyze that this algorithm will be.
I'm muted. Thanks for letting me know, my doggy. Um, I fast forward through the things that that are kind of like it's just reviewing this stuff. I don't know if you're familiar with any of this, but pretty much think about like someone that wants to learn this shit as fast as possible. And then that's me. Hello.
Much better than this algorithm, because here there is only one statement which is a constant statement.
It's about data structures and algorithms, which is how you keep things like organized in a game or in an app.
And here we are iterating in a for loop where this line gets executed for n number of times, because this loop goes from 1 to less than equal to n. So let's try to execute this code in Eclipse and see that how much time these algorithms are taking. So friends, here you can see that we have
So basically when you're making a program like a game like say Fortnite or World of Warcraft, you need to store all of the items into like the items, like data. Like imagine all the folders that it installs for you. It has folders for like all the assets, the animations, the blah blah blah, the blue blue blue, all of that shit. You feel me? You need to like um make this program go fetch these things. Like whenever you press a button to jump, you need to fetch the animation and plug it in with the function of jumping, so then your character doesn't just like move up, he's like actually like freaking jumping. So like in order to like go fetch all this data, you need to have it very well organized, and to have it well organized you need to know a lot of things about data structures and like how to go fetch the data, because some data is harder than other data to go fetch. For example, if you throw a rat in a maze, there's like only one way to get through the maze, right? And there's just gonna be only one way to go check if it's a dead end, and that way is to go check if it's a dead end. So you could probably write some sort of like algorithm that goes straight, picks the first left, goes straight, picks the first right. So like that's like very like like up in the air type stuff. But if I make a list and I say, this is a list of colors, red, blue, green, then I can go select one of those specific colors and assign it to something. For example, in a data structure, we're gonna do different things. For example, I don't know, the second user that just joined, like add some data to it to like define who it is, like your email, blah blah blah. Like this data structure thing is how everything is built, like in the back end of things. Um, like Uber probably has a whole data structure where it like has the users that can ride in a car and like the drivers probably, and like when user A is online and the driver is also online, then it can like talk to those, fetch the data, and like have them, join the ride. But if the structure didn't exist, where would the application even look for? You know what I'm saying? So say you have to do that a lot of times, you're gonna want something smaller than something larger. Um, and this hieroglyphic looking stuff is pretty much how you talk to the computer um, for it to go find things for you. It's really simple, just that it looks kind of weird at the beginning. And I found this tutorial that's like freaking 2 days long, and I'm about to sit down and watch it. I'm already understanding a lot of stuff. I don't know anything.
Are taking.
So what he's explaining right now is about the time complexity of going and fetching for the data. So Ramesh on the left hand, he made a formula where he grabs the number that's n and then does some math to it. And then Suresh did a lot of things. He grabs something that's called sum, something that's called I, something that's called n, and then it has it loop and like do calculations until the requirement is met to stop looping. That is so much compared to Ramesh's thing. Ramesh's thing was just like grab a number, do the math, and that's it. On the right, you would have so much data, so much more data happening than on the left. On the left, you wouldn't have that much stuff happening. So for a computer, if you're doing like millions of things, you're gonna want it to do like just time complexity, I guess. I guess I understand.
So friends, here you can see that we have written this both the algorithms, and inside our main method we are simply calling this find sum method. Now here what we are simply doing is, when we run this main method, we are storing the current time in this variable. Then we are executing our find sum method, and at the last we are again calculating the current time, and we are simply subtracting this time, so we can get the time taken by this algorithm.
Alright, so this I don't understand, so I'm gonna have to look at it a little bit. Time complexity demo main string arms double now equals system. Oh, so this is gonna print out in milliseconds how long it took to run this.
And if you see, it gives the time in milliseconds. So if we run this algorithm with a very large value of n, you will find it will take almost no time, because this is only a single statement where we are providing this value of n into this mathematical formula. So if I run this, so this is the sum of first n natural numbers of 99,999, and here you can see the time taken is almost 0 milliseconds. Now let's say if I comment this part and I uncomment this, so now if I run this algorithm again, so now this algorithm will be executed. So here you can see the answer is the same, but the time taken is almost 2 milliseconds. So here you can see that though we have these two algorithms which solve our problem, we usually do the analysis of the algorithms to get the best algorithm out of the options.
Wow, people be like, Timing their algorithms. That's crazy.
And also, friend, calculating the time taken by algorithm by this is also not good idea because this depends on machine to machine. So it is just giving us a rough estimate about the time taken by these algorithms. But when we do analysis of algorithm, there are different mathematical tools which can help us determining the time complexity of an algorithm. So this was all about the time complexity of an algorithm. I hope you liked this video. Thanks, have a nice day.
Hi, and welcome to my guide.
Hello everyone. So in our previous video we discussed about the time complexity of an algorithm and we will discuss more on this in our upcoming videos. So in this video
Okay, so he logged like the milliseconds. I wonder if you can log like the date.
we will discuss about the space complexity of an algorithm. So the first thing which comes into our mind is what is space complexity. So in simple terms you can say that space complexity is basically the amount of memory or space taken up by an algorithm to run. So friend, let's say we have these two algorithms written by two different programmers, Ramesh and Suresh. Now in order to determine that which is the best possible algorithm, one constraint is the time complexity which we discussed in our previous video. The other is the memory required to process the input by an algorithm basically helps in determining the space complexity.
Right.
So usually we even measure that how much space this algorithm is taking and how much space or memory this algorithm is taking, and whichever is taking the less memory, we simply choose that algorithm. Because when we run these algorithms with the system having so many users, it may happen that our memory get exhausted. So we try to fit in the best possible algorithm which takes less memory. So here when we calculate the time and space complexity, we never go into the exact numbers. There are certain mathematical tools which help us in determining the time and space complexity of an algorithm.
Show me.
And we usually term them asymptotic analysis of an algorithm.
Show me.
In our upcoming videos, we will discuss more about the asymptotic analysis and its notations. And we'll also discuss how we can use those mathematical tools to determine the time and space complexity of an algorithm. I hope you have liked this video. Thanks, have a nice day.
I love this video.
Descubre Wix Studio, la plataforma web para agencias y grandes empresas, donde la libertad creativa se une a la eficiencia total. Los elementos escalan por defecto en perfecta armonía y hasta los diseños más complejos se adaptan.
Hello everyone.
Hi.
So in our previous videos, we discussed about the time complexity and space complexity of an algorithm. We saw how time and space affects the performance of an algorithm. But usually we don't go by the exact numbers that how much exact time an algorithm is taking. or how much space in
30 minutes in out of 48 hours.
numbers an algorithm is taking. So usually there are mathematical models which help us in determining the time and space complexity of an algorithm, and the analysis which deals with those mathematical models we
Asymptotic analysis of an algorithm.
term it as asymptotic analysis.
And let me write that down.
So what do we mean by asymptotic analysis? Asymptotic analysis helps in evaluating the performance of an algorithm in terms of input size and its increase. So let's say we are given an algorithm with certain input size. We use this asymptotic analysis and determine the performance of an algorithm. So this study also helps us in determining, let's say, if the input size is less, then how much time the algorithm is taking, and if we increase the input size, then how much time or space the algorithm is taking. So usually when we do this asymptotic analysis, we don't actually measure the actual running time of an algorithm. This analysis simply helps us in determining that how time and space taken up by algorithm increases with the input size. So as we already discussed, that if the input size to an algorithm is less, then less time and space will be required by the algorithm to process that input. And if we slowly increase the size of the input, usually the time and space will also increase. So this asymptotic analysis helps us in determining that increase. And also when we perform this analysis, there are certain notations which we need to know to perform the asymptotic analysis. So we'll discuss about the asymptotic notations in our
Asymptotic analysis helps in evaluating performance of an algorithm in terms of input size and its increase. Using asymptotic analysis, we do measure actual running time of algorithm. Oh, it helps in determining how time and space taken by algorithm increases with input size. Bro, this sounds straight out of a science fiction freaking movie, dude. It helps in determining how times and space taken by algorithm increases with the input size. Yes, please. Um, yes, please. So, I kind of want to do like a little testy here. Update now to the latest version, and it failed miserably. I don't even think I got Visual Code installed correctly, but it's okay. I don't really need to update it. People have been doing great without that version that they want me to get. Okay, so let's see if I can remember how to do this. View terminal. Okay, so in this one I can do I need to make a React app. It's a command. It is really dumb. I already forgot. Create React app. Sorry, guys. npx. Do I have to? How about that? need to install the file, create React, add for character C. How? Pissing me off. I don't even know how to make it a thingamabobber. Like how? Bro, if NPX. What the frick? New file. Something that JS. And then here can I do constant equals can I make already a class? Class equals character. I wonder if I can already do this. This is probably not how it's done. I forgot. I'm not gonna fuck with this. What do I do now? Int apple equals 6. Let's see. Is this even? How would you run this? I don't get it. Wait. Does this do it? But this will literally log. But where the frick is it? Bro. Console that log. Console that log. Hello world? Bro, I don't even know where to. Why doesn't it work? I quit life. I quit life.
Our upcoming videos. So in this video we simply discussed about a basic introduction to asymptotic analysis. In our upcoming video we'll discuss about the asymptotic notations and the types of asymptotic notations. I hope you like this video. Thanks, have a nice day. Hello everyone. In our previous video we discussed about the asymptotic analysis and we also discussed about its basic introduction. That asymptotic analysis helps us in determining the runtime complexity and space complexity of a given algorithm. So usually this asymptotic analysis is being done by asymptotic notations. So what do we mean by asymptotic notations? So if we see the definition of it, asymptotic notations are the mathematical tools used to describe the running time of an algorithm in terms of its input size.
I already overloaded myself with fucking information.
So here we will discuss more on these mathematical tools, that what are those and how it helps in determining the running time of an algorithm. So in order to understand about these asymptotic notations, we'll take an example. Let's say you go to a car showroom where you want to purchase this car. So mostly you will look into the design of the car, and to the salesman you will ask one most important question is what is the performance of car in 1 liter of petrol, that how much this car travels in 1 liter of petrol. So basically the salesman will never give you an exact answer. He will simply give you the numbers based on certain conditions the car is running. So he will simply tell you that if you are running this car on highway where the traffic is very minimum, this car can give you a mileage of 25 kilometers per liter. And if you are running it in a city where the traffic is max, it will give you 15 kilometers per liter. And let's say if you are running for some amount of time in city and then in highway, which means you are encountering an average traffic, so it will give you around 20 kilometers per liter. So these are the three answers which salesman might give you when you ask about the performance of car in 1 liter of petrol. So when we talk about an algorithm, these asymptotic notations give us this rough idea that how an algorithm will be performing in certain situations. So here the asymptotic notations help us in determining the best case, average case and the worst case. So you can simply relate this analogy to these conditions, that best case would be that if you are driving on a highway, the average case would be that you are driving in both city and highway, and the worst case would be that you are simply driving in the city. So this is how asymptotic notations provide us an in-depth description about the running time of an algorithm in terms of its input size. So in our upcoming videos we'll discuss that what are the asymptotic notation types and how we can use those types to determine the running time of an algorithm in terms of its input size. I hope you like this video. Thanks, have a nice day. Hello everyone. So in our previous video we discussed about asymptotic notations.
I'm so hungry.